Welcome to the updated demo for the Army Promotion Point Dashboard. I'm going to go over some of the things that I left out in the previous one and some of the updates that I've made. So once you load up the page, all of these are going to be blank until you load in your data. So this basically feeds the data into the site and informs everything that happens below. Okay, so green button, load data. What's going on here, why there's a drop-down menu is because this is a workaround to basically allow you to make your insert your promotion points and get around the DoD limitation on write permissions. So if you're on a home network or basically anything that's not DoD, then you're able to type. Otherwise, you're going to have to use this super ugly drop-down menu, and I apologize for that, but that's all we have for the time being. Dark mode is also prohibited on DoD networks, and these checkboxes down here, you are not going to be able to use these on DoD networks. Okay, so once you've got these in to include your what your points are at right now, these dial graphs will not load unless you have your promotion points at the top. Okay, because that's what they're based off of, what your promotion points are versus the historical data. So one thing that I want us to establish is that there are different trends in different over different periods of time. So look at this. This is a good example. This is 11 Bravo, and there are other MOSs that have these patterns where there is a section of months that are particularly low, and then there's a section of months that are a little bit higher. It's distinct. They're not super high, but they're what they are. So what the ordinary least squares model, a regression model, does that predicts your next month's promotion point cutoff. It is going to basically find the reduced mean squared error. So what that means is it's shooting a line where the difference is lowest between the different points. And then it's going to make a prediction based off of that. So consider this. This is what your ordinary least squares regression model looks like. You can look it up. It's the same math across the board. Okay, so it is going to be less accurate if there are two different trends in your data and you are trying to make a prediction where you believe that one of those trends is the more dominant one. Okay, so what I mean by that is, look, these lower points, they end in May. These higher points begin in June and they end in April. Okay, so let's say that you want to make a prediction for, let's say it's May or March right now, and you want to make a prediction for April. It's thinking that it is going to be 509. So that's the prediction it makes. But actually the points are much lower at 447. Well, that's because it's taking into consideration this trend that is no longer the dominant trend. So what you do is you cut that period of time off. Okay, so you begin in June. So you go from June now to March. I'll just show you. Now instead of 509 or whatever it was, you have 452. Okay, our prediction is 452, and next month's points are 447. That is a 5-point difference in prediction just because you have sectioned off your data to capture the more relevant trend. Okay, so what the line is based off of is the bias of all your data, not the actual points themselves. I mean, they are, but this is why if you have if there are periods of times where there are insanely high points, it'll skew where that line is drawn. So please consider that when you're doing this. Don't get on me because the math is solid. Also consider that I don't know and the math doesn't know what the needs of the Army are. So this is only going to be as good to whatever end that is. This section here just shows you how many people over that period of time were able to get their promotions. The dial graphs will go into the math that goes behind the Bayesian adjusted promotion probability. It's less so Bayesian than it is evidence-based volatility assessments and how that impacts your rating. So we'll go down and we'll talk about that in the second section. The historical point fluctuation graph, what this is it gives you a snapshot of what the volatility is for your MOS. That volatility comes into account when looking at this evidence-based or Bayesian adjusted promotion probability. And so I'm not going to show you that number because it's basically worthless to you. Just looking at this from your perspective, but this is a nice visual for you to get an idea of what basically has been going on. Competitiveness score shows you the number of people who got promoted with respect to the number of people who were eligible for promotion. So the competitiveness score basically shows you how competitive you are versus the average soldier. So the higher the competitiveness score, more competitive you are. And then we have some very simple graphs that I'm not sure I really need to explain. It's just a visual that shows you how many people got promoted. And then over here is the raw data where you can see how many people were eligible versus promotions. How these graphs were generated is based off the data that lies here. So we'll move on to the next section now. So now we are going to go into the second part, which is going to discuss what the evidence-weighted promotion probability is called. So in order for this Dow plot to load up, you need to have your promotion points here at the top. It will not populate unless you don't, because that's what the Dow plot is trying to predict. It is saying next month, based off of your promotion points and the history of the data, considering volatility, I think that your chance of promotion is X. Okay, so that is how that works. We're going to go into the actual math behind it. All right, so we're going to define our terms, and then we'll talk about the actual equation that we're using. So this is very simple. I'm going to try and find more advanced ways to make this prediction. So we'll just talk real quick. How does this work? So it takes first your historical promotion probability. All right, the number of months that you would have promoted over divided by the number of months that there were. So if you had a 9 out of 10, or even let's say 10 out of 10 points, to have promoted 10 out of 10 months, your historical promotion probability would just be 1. Your absolute change is going to take into consideration the change over a given month. So for every ith month, the next ith month minus 1, so the previous month, what is that percent change? So it's going to take into consideration all of those. It's going to get the absolute change, and then we're going to set a volatility threshold. I have started with a volatility threshold of 75%. I'm working on adjusting it in a way where it works well for most MOSs, or finding some other way to do this in a way that's more accurate and less punishing, because as we're about to find out, this is a very punishing metric. So we will then go in to try to find the volatility factor. So what this does is this applies to what your current points are, and then punishes those points. So takes the number of high volatility months, and we get the number of high volatility months based off of the number of months that violate that volatility threshold. If there are 3 months out of 10 months that violate that 75th percentile, then your odds are going to be punished by 30%. And there's nothing you can do about that. And that's somewhat intentional, because I would like you to be not pessimistic, but grounded in your expectations of promotion. I don't want you to think that you are going to be promoted when you're not, and obviously not to take anything on this site as gospel. So once we calculate our volatility factor, we are going to, like you said, apply that to the historical probability factor. The 1 minus this is very common in statistics. So the final equation ultimately is the number of months that you would have promoted, and your probability of promotion based off of how many months you would have promoted, punished by the volatility factors. So let's think about that for 1 second. All right, if you were going to be promoted 10 out of 10 months, but there were 2 months that the model has deemed to be to have violated the volatility threshold out of 10. All right, so now you have you've been punished by 20%. So what this is saying is that it is taking 80%, or it is taking your promotion probability and then multiplying it by 0.2. So like punishing it by multiplying it by 0.8, which is punishing it by 20%. Even though it's to no fault of your own, your odds of being promoted are now going to be much lower than they otherwise would have been, according to this model. Obviously, you can discount it as required, but if you are like a Korean linguist and you need your expectations to be grounded, then this is it's not something that's going to make you happy, but it's something that might be a little bit more worth looking at. So consider that. That is all for the explanation of the evidence-based, evidence-adjusted promotion probability.